Hello students, welcome back to OrganiChemVerse YouTube channel. In this video, I'm going to explain what is the relation between halogenation and isomerism for certain reactions. You can come across questions like upon monochlorination, how many possible products will be formed, or upon dichlorination, how many isomers are going to be formed. So in order to understand this, you need to know what is halogenation reaction and what are isomers. What is halogenation reaction? We know that when an alkane, so let me take an example of say methane, right? When we take methane in presence of chlorine and sunlight, it undergo halogenation. To be precise here, chlorination, because we are using chlorine. It forms chloromethane. This is monochlorination. Suppose if you use 2 moles and 2 hydrogens are replaced, right? So instead of CH2, CH3Cl, you are getting CH2Cl2 like this. Then we call it as dichlorination. And it goes on trichloro, tetrachloro like that. This is halogenation of alkane molecules. Now, what about isomerism? When you have different types of carbons or hydrogens in a molecule, what does that mean? Let's say we take propane molecule. In propane molecule, there are two different types of carbons. We have primary carbons and we have secondary carbons. And these two primary carbon or methyl groups are symmetrical in nature. Why they are symmetrical in nature? Because when you draw a line, right, it is, you can cut the molecule into two equal halves which are mirror images. So we call that as symmetrical. Or in simple words, when you remove hydrogen from either here or here, you are going to get a same product, that is 1-chloropropane. We can even remove from secondary carbon. So you are going to get 2-chloropropane. And these two are isomers. In fact, these are positional isomers because the position of the functional group, that is chlorine, is at first and second carbon. Therefore, it is forming isomers. The formed products both are haloalkane, but they are not same molecule. They are different molecules. Therefore, what happens whenever you start an alkane with different types of carbon, you will end up with mixture of products. The question is how many products are formed. So in order to understand this, you should know how to count different type of hydrogens, whether you are replacing primary, secondary, tertiary hydrogen is important. In the given question, you're supposed to predict the products for ethyl cyclohexane. The ethyl cyclohexane structure is already given. Even if it is not given, you should know how to convert ethyl cyclohexane, the UPAC name, to its structure. Right? So let's write down here. This is the molecule. Let's count different types of carbons we have. So look at this. This is primary. So upon replacing, I am going to get one product. This is secondary. Upon replacing it, I will get two products, right? That means 1 and 2. Upon replacing this hydrogen, I will get the third product. But look at this carbon and this carbon. Are they symmetrical? Yeah, because both of them are attached to the same carbon. So whether you remove from here or here, you are going to get the same product, that is product number 4. When I remove from here, I am going to get product number 5, which will be same as when you remove from this position. Remove hydrogen and replace it with chlorine. Same as here. Can we remove from here? Yes, we can remove from here as well. Therefore, how many products are we going to get here? We are going to get 1, 2, 3, 4, 5, 6. 6 monochloro products will be formed in the reaction. If you keep writing what are the products formed, for example, in this case, If you remove hydrogen from here, you are going to get CH2Cl. When you remove from here, CHCl. Like this, if you keep writing, it will take lots of time. It will take at least more than 3 or 4 minutes, and you will not have so much time for each question. So max to max, you have to spend only 1.5 to 2 minutes in a question, assuming it's a very difficult question. So you need to find a trick how to predict the number of products. Therefore, for the given question, the number of products will be, the number of isomers formed will be 6. The right option is option A. Thank you for watching this video.